All right, let's take a look at example 1.3.5. In 1990, the population of Canada was approximately 26.6 million. The population projection for 2025 is approximately 38.4 million. We're in 2025, so we can see if this was right or not. If this projection was based on a geometric sequence, that is an assumption, what would the annual growth rate be? That is the common ratio. Given that this is a geometric sequence, what assumptions would you have to make? I mean, the biggest assumption you have to make is that it gets bigger the same amount each year. Which maybe roughly it does, maybe roughly it doesn't. But first off, let's examine our geometric sequence. This one we're going to need 3 rows for. Right? Because we're going to have year, term, and population. So in 1990, that's term 1, we have about 26.6. Population is measured in millions. We don't need to write out the whole number, we just do millions. Then this goes up a whole bunch of times to 2025. And the population is 38.4 million. Okay, well, the first thing we need to do is we need to determine which term this is. So term 1 is 1990, right? We can do 1990 take away 1 is equal to 1989. So the year is 1,989 larger than the term. So I'm going to do 2025, take away 1989, and I am going to get 36. This will be the 36th term. Now again, I know my first term, I know my 36th term, I need to find the common ratio. I have 2 pieces of data. Got my first term, got my 36th term. We are going to use 2 equations again. So let's just remember our formula. Our nth term is equal to our first term times our common ratio times n minus 1. We do not know our common ratio. Okay. Now, what happens when we plug this information into here? Well, let's see. N is equal to 1. So term 1, we've got 26.6 is equal to 26.6 times r to the power of 1 minus 1. It doesn't help us at all. Right? Sorry, it's 26.6. So this is 26.6 is equal to 26.6 times r to the power of 0. R to the power of 0 is just 1. All we get is 26.6 is equal to 26.6. That doesn't help us at all. So let's go and look at this equation and solve it. So we've got our n is equal to 36. So 38.4 is equal to, term 1 is 26.6. I'm going to run out of space here, so I'm going to move it back a little bit. $38.4 is equal to 26.6 times r to the power of 36 minus 1. So this is 38.4 is equal to 26.6 times r to the power of 35. Now we need to isolate our variable r. So I'm going to divide both sides by 26.6. So I bring up my calculator. I get 26.6 divided by, 38.4 divided by 26.6. 38.4 divided by 26.6. 1.4436. So r to the power of 35 is equal to 1.4436. Now, to solve this, we need to do the 35th root of this to get r by itself. And Desmos allows you to do the 35th root. It's not too hard. Your regular calculator might not. I'm not 100% sure, but I've got a calculator here that does this. And I type in 35th root of this. I get 1.0105. 1.011. That's my R. Now, the actual values I've got is 1.010545104449, but we'll round it to that. This is 101.1%. That means that each year, the population is 101.1% of the previous year. Or the population goes up by 1.1% each year. We're assuming that it goes up the same rate every year. Probably doesn't. But we'll say it's close. And this projection is off because the population of Canada is approximately 40.1 million right now. So there you have it. If you know term 1, and you know a random other term in the sequence, you can determine the value of r.